to obtain K in global, then you have to multiply the L, K, L. So which is all of this 6 by 6 multiplied by 6 by 6 and 6 by 6. So if you solve this using this approach in your test or exam, I'm very sure that you are not going to complete your problem at all. You are not going to complete your test. So this is your K, which is we have 6 by 6 in the local. So this is what I meant to you just now. We have to prepare everything in the local coordinate first, and then we transform it into the global coordinate system, which is you have to multiply by the transpose of the transformation matrix and again multiply by this transformation matrix, which is very, very tedious work and very huge calculations. So let's we look at this problem. But yeah, what we are going to go through later, please keep in your mind that I'm not going to solve every single degree of freedom. We may demonstrate several elements in our K metric just to prove that the equation that we are going to use later actually giving us equivalence, similar result if you solve by using the approach that prepared to you in the lecture notes. So using this example, so we have so I have this at each nodal point. So I list everything. So U3, V3, and we call it this as V3 prime, refer to the rotation. 1, 2, 3, 4. Okay, here for U4, V4, and V4 prime, everything also will be equal to 0. But in this problem, as you can see here, we have 6 unknown degrees of freedom, which is still very big in terms of the number of degree of freedom ataupun apa tu, number of unknowns parameter yang kita nak cari tu. Then actually this problem you cannot solve this problem using your calculator because your calculator is limited up to 3 unknowns only. So 3 unknowns only. So this one you have to solve by using maybe Excel, maybe you have to actually you can do manual solve this manually, but you have to solve big system lah itu je. So okay, let's say instead of we use a Q, so I just call it U2 V2 and V2 primes. So here we have U1, V1, and we have V1 prime, which is to refer the horizontal and vertical displacement and also the rotation at each nodal points. All right, now what is the first step that we need to prepare? The first step that we need to prepare is, in this case, for example, you have to prepare the K matrix in local coordinate system, which is for the element number 1. What is the element number 1 in these figures? Okay, the one that is position in perfectly horizontal. So for the frame elements that lies on the horizontal line, so the global K, which is equal to the local K. So that's why we have this due to the and this is due to the theta equal to 0. So the local equal to global. All right. But for the element other than 0 degrees, then you have to work with the local coordinates. Yes, local coordinate system first, and then perform this kind of analysis in order to transform from the local to the global. So then after you have this prepare, and this also might prepare, and then you transform this to get L transform, and then process L, T, K, and K prime and L, then you will get K global. Then after that, you will assemble all the K, K1, K2, and K3. To obtain the K global of K global of the whole system. Now the K global of the whole system. So at this stage we have the K global as well, but it is precision optical system. K global as well written in on the global axis, but it is written for the each members, right? So this one is for the whole structures yang kita ada tadi tu. Alright, now this process here, which is will consume, I think, so much time, and then you it's also prone to error. So you may face so much error here. Because kita apa, kita nak darabkan yang ni dengan elemen yang ni, and then you can imagine lah, you have so many element, and then you need to multiply by K, your K, this is your LT. So your K, you ada 3, 4, 5, 6, 2, 3, 4, 5, 6. And then nak darab lagi dengan yang ni, yang 6 by 6 lagi ni. So when you plug in and multiplying part by part ni, then the possibility from the human error lah, kan, human error. Kalau komputer, if we supply a correct information to the computer, then biasanya dia takkan ada error. Otherwise the coding itself yang generating the error. But for us human, kalau kita nak buat multiplication ni yang banyak ni, I believe that when you come up with the final solution di sini, then you will find maybe your metric is no more diagonally symmetry, kan? Which is K should be diagonally symmetry. So let's say ada beberapa tempat yang kamu ada error, kan? Kira-kira tengok tak sama lah tempat dia ni. And then you will be in trouble lah, nak kena cari lagi, kan? So to avoid this problem, so we actually introduce with what we call it a set of equation which will prepare the data straight away in the global coordinate system, but it's still in the element punya stage. Okay, element punya stage. Sebagai contoh, let's we look at this up. Okay, let me show you the equation first. So this equation we will supply during the test and exam. So you have to, I recommend untuk problem yang sama dalam kamu punya lecture slide, Okay, cuba solvekan problem tersebut dengan menggunakan this document. Actually, this document saya dah share sejak daripada awal semester lagi dalam kamu punya e-learning. And then you have to be careful. Okay, T here, which is refer to the transformation. Kalau dalam lecture note, kita panggil dia sebagai L metric, right? So T actually here refer to the transformation. And C, which is equal to cos beta. And S equal to sine beta, which is the angle beta actually refers to the inclination angle of your element. Kalau sebelum ni kita panggil dia theta kan. So dalam this document, kita panggil dia beta. Actually dia merujuk kepada benda yang sama saja. Alright, so instead of okay, untuk let's say for the element which is the inclined to zero angles, so we know that the kg in the element stage equal to k prime in the element stage. So dia sama. Tapi once we have angle other than zero, okay, so this is when the angle is not equal to zero, so we cannot take this assumptions anymore. So, tapi in this document, okay, you are not required to do the transformation T, K, T anymore in this case. Kita pakai T kan. So yang ni this process here, your KG, in the element stage, as you can see here, this is in the element stage, which is you have to solve for every single element in your frame structure. So this process can be ignored. Actually, dia bukan ignore. Actually, we have already simplified. So we have this T, and then we multiply by K prime, and then we multiply by T. Then we come out with this metric, which is for whatever angle of inclinations of your element. So when you plug in the numbers into the this K matrix equations, then it will give you directly your K in the global coordinate system. So tak perlu nak buat this multiplication process lagi. Alright, let's retry. Okay, let's retry to prove whether this K in this document will provide the similar result as what we have in the lecture notes. Okay, sebagai contoh, kita ambil element number we are working with. Nanti saya adjustkan dia punya ni sikit supaya dia berada pada position yang sama. Alright, now let's we take element number 2 kan, element number 2. Okay, where is our element number 2? So this is our element number 2. Okay, element number 2 in terms of the element connectivity, it is connected from 3 to 1. From 3 to 1. So it is connected from 3 to 1. So what is the angle from 3 to 1? So kita ambil this as the starting line for the angle. Then we project the angles to the elements. So our beta here for element number 2, which is equal to 90 degree kan. So 90 degree, okay. The length of our element adalah 8 feet 8 feet tall. So let's we work out with this. untuk elemen nombor 2 saja. So now if I can take the cos and sine wave, and then for the sine pada 90 degrees angle, dia adalah memberi positive 1 dia punya results dia. And then for the 270 kita ada negative 1. So this is for the sine curve. And then for the cos, we have something like this lah. Alright, something like that. Saya lukiskan elok sikit. So it should cross this part here. Okay, roughly lah kita apa ni, not to scale kan. Macam tu lah roughly. So okay, then we know that C, which is cos beta for angle 90 equal to 0, and sine which is equal to sine beta. Ini terbalik ni. Cos kita dapat 0. Okay, sine adalah 1 in this case. So we are looking for beta equal to 90 degrees. Alright, then what else we need in order to plug in? Let's say we just look at this element in our K2, in our K2 kan. So kita perlukan C, kita perlukan S, dan kita perlukan K, kita perlukan Q. But what is K? K adalah EA over L dengan EI over L cube for the Q. Okay, but what is our saya copy dia punya ni problem dia. Okay, kita ada dekat sini, we have E, which is 30 times to 10 power of 6 pound per square inch. I given 65 inch, and then we have area which is 6.8 inch square. So once you have this, and then you know the L, which is 8 feet, which is equal to 8 multiplied by 12 in inch. All right, now we need to prepare this information so that we can use it in our matrix. So K is given by AE over L. So if can someone any one of you calculate what the value of K for structure number 2? And then also calculate Q, which is Q is given by EI over L cube. So please help me to get this to get the value for these two variables. So what is the number here? 4K? Anyone? Please help me. Ada orang ke tak ada ni? K 25.5 time to 10 power of 6. Lagi satu, Aiman. Asyik Aiman je ni respon, yang lain mana semua pergi hilang. Alright, now we have all of this information which is enough for us to calculate the first information in our K matrix. So kalau tengok K matrix ni disediakan in such a way that they just present only the half part of the matrix. So hopefully you should be able to understand lah kan, how what the number should be there, what the number should be there and there. So kat mana lagi? So we have there and there. So you should be able to understand this. Nanti jangan pula tanya mana hilang lagi separuh dekat atas kan. Alright, now let me use these numbers to calculate the first element in our K matrix, which is in this case given by
Sir,
yeah.
yang Q saya tu saya tak perasan pula ada L kuasa 3. Yang yang
Berapa?
baru ni 3.81 darab 10 kuasa 6.
3.81 darab 10 kuasa 6. Okay. So terima kasih ni Aiman. So we try to calculate the first element dalam kita punya K matrix, which is given by KC square plus half QS square. So cuba dapatkan berapa nilai dia. Kita ada C kosong, C kosong S1. So this part will be 0. It doesn't matter whatever value you have for K. And then plus 12 multiplied by Q multiplied by S, which is 1 square. So please help me again to obtain the value for this term here. Half QS square.
Doktor, yang nilai K tu patutnya 2.125 sebab yang 25.5 tu kalau bahagi dengan 8 feet. Tapi yang feet tu kan tukar inci kan? 8 kali 12.
You have betul, kena tukar semua dalam ni. Jadi berapa kat sini?
2.125.
2.125. So minta yang kawan-kawan lain check sekali lah. So yang ni okay, sebab dalam this case dia multiply by C dia akan jadi kosong, tapi dekat tempat lain dia mungkin ada multiply by S kan. So 3.1 darab 10 kuasa 6 darab dengan 12 berapa jawapan dia? Lamanya you all nak cari yang ni. Q 2204 betul? 2204.05. Okey, kita ada 2204.
Yang Q tu yang bawah K tu. EI over L power of 3.
Q.
Uh-huh.
Q adalah yang ni lah. Ni, yang ni.
Kita bahagi
EI
dengan L power of 3 kan?
L power of 3, betul.
So kalau saya kira saya dapat 2204.05.
2204.05, okey.
Betul Syafiq?
Okey, tak apa. Let's say untuk elemen number 2 ni kan, kita dah kira untuk this position kita dapat 2204.05. 2204.05. So okay, Syafiq dah verify dah tu, betul. Now let's we compare these numbers dengan yang kita kira. Kita dapat berapa ni kat sini? K2 which is 2 point berapa ni? Untuk elemen number 2, untuk elemen pertama, then we should get 2.65 to the 10 power of 4. Dekat mana yang tak betul ni kat sini ni?
Saya maksud saya Q tu nilai Q.
Oh, nilai Q. Okey,
Ah.
okey. Cuba darabkan dengan 12 lah.
Ada dapat 26. 26
okey, okey. 26. Berapa 26?
48.5.
48
448
Yes.
2448. Okay, so this number which is sama tak kan? Sama dengan yang kita dapat daripada ni. Ni numbers yang kita directly dapat daripada this equation which is should be equivalent dengan yang ada dekat sini ni. Tapi jangan lupalah kat depan dia ada 10.04. Tapi ini untuk satu elemen. Tapi saya tak sempat dalam lecture ni kita tak sempat nak buktikan semua sekali. So saya recommend kamu go through, tak perlu buat semua pun. Mungkin boleh ambil yang ni. Yang ni sepatutnya jadi kosong sebab everything yang kita ada darab dengan C kita kosong kan. Cuba kita tengok 1, 2, 3, 4, sini 2. 1, 2, 3, 4, 2. Okay, sama nilai dia kosong. So whatever yang kita ada yang multiply by C, dia akan jadi kosong. Atas dia kosong, so kat sini pun kosong. Cuba cari yang ni sama dengan yang ni. Okay, then kita just, sorry, yang ni dia terbalik. KS square. So yang ni pun kamu boleh cuba ni lah. Kita dah ada, yang ni multiply by C, so akan jadi kosong. So K kita ada, tapi S dia 1. So kita akan dapat berapa tadi yang kita dah kira K. Kita punya K adalah, okay, ini kita punya K 2.125 dan 10.6. So dia akan jadi 212.4 lah. Okay, so ini yang kita ada 212 kuasa 0.5 darab 10 kuasa 4. So as you can see now, this is to demonstrate how easy to use this approach instead of yang kamu ada dekat slide ni. Okay, the whole process of the multiplication tu yang kita buat as transformation multiply by K in the local coordinate system and then multiply again by the transformation matrix, which is very huge process. Kita dah simplifykan dia by providing you this equation which is in the element stage, but it's already written in the global coordinate system. So saya minta kamu cuba bila buat latihan ataupun assignment later, jangan guna approach yang ada dalam lecture notes ni. Just straight away guna approach yang ada dalam dokumen yang separate dokumen yang yang saya supply dalam e-learning. Boleh tak kita ada sikit masa lagi, boleh tak kita cuba verifykan yang ni 2 QL square, which is the number should be equivalent to 4063 times 10 to power of 4.
Doktor nak tanya, kalau formula ni untuk yang simetri je ke boleh pakai atau bentuk-bentuk beam lain tak kisah?
Semua boleh pakai untuk frame. Untuk apa ni, yang simetri tu hanya melibatkan dia punya boundary condition saja. Dia tak let's say kalau simetri tu actually hanya melibatkan the treatment to the boundary condition saja. Okay, dalam kes ni kan, let's say kamu still ada 6x6 ni dekat sini ni. So bila kamu nak selesaikan this schematic, dia still kita pakai approach yang sama. Kita tengok boundary condition dulu yang perlu kita eliminate, so kita eliminatekan terus kan. So daripada 6 kali 6 ni, tak semestinya kita nak kena solvekan 6 kali 6. Mungkin hanya satu elemen ataupun dia akan reduce kepada 2/2 sahaja kan. Mungkin dia akan reduce kepada yang ni je. So nanti yang ni je yang kamu nak prepare. Untuk simetri, kalau soalan untuk simetri tadi tu, dia tak ada mengena dengan yang ni. Tapi dia actually lebih kepada treatment kepada boundary condition. So bila kamu dah tahu boundary condition apa yang mewakili simetri problem tadi tu, symmetrical problem. Let's say kamu punya frame kamu bentuk macam huruf M, macam gini kan. And then sorry, dia punya saya lukis mula. Let's say this is the ground ataupun the floor. Then you have a structure which is mungkin macam bentuk M macam gitu kan. So the support and also the force yang apply kepada, kita nampak bentuk dia pun, bentuk dia ni simetri dah ni. Simetri about this axis kan. So the one on the left has the same geometry as the one on the right ni. Left and right. And then lepas tu tengok dia punya loading. Loading pun sama kan. So if the geometry the same, the loading the same, then we can instead of we solve the whole thing, so we just take only the half part. Nak ambil yang belah kanan saja pun boleh, nak ambil yang belah kiri sahaja pun boleh. So tapi boundary condition kat sini dia kita gantikan dia dengan roller untuk menunjukkan simetri. So bila kita gantikan dia dengan roller due to the symmetry boundary condition, then dia apply lah kat sini which one will be active and inactive kan. So sama macam kita apply yang roller pada problem-problem yang lain lah. Adakah saya menjawab soalan?
Kasih tu.
Okay. Dah dapat 2 QL square. Yang kita nak cari ni yang ni. Kalau someone of you can calculate this quickly. $40 63 darab 10.04. Amirul, okay, terima kasih Amirul. So daripada Amirul kita dapat from this equation untuk 2 QL kuasa 2 which is dia punya position dia pada row 6 kolom ketiga. So kalau kita pergi kepada dalam slide tu, row ke-6 kolom ketiga, so kita dapat number yang sama kan. So this is, we have proof actually. Kalau kita solve the transformations of the metric from the local to the global, kamu dapat result dia macam gini. Kalau kamu pakai apa ni, the equation yang kita supply dalam separate document pun kamu akan dapat result yang sama. So nanti bila test nanti ke ataupun ujian ke, anytime bila kamu dah kerja ke nanti kan, you have to use or you have to solve the frame structure problems. Then kamu dah confident dah, okay ni sama je kan. Kamu tak perlu buat matrix transformation lagi. Pakai equation ni, actually dia dah transform dah, siap-siap kan untuk kita je pakai je. Cuma nak kena tahu what is K, what is C, Q and S. So bila yang tu dah kira, then we just substitute untuk dapatkan value dalam setiap elemen dalam K matrix. So itu untuk satu elemen. Untuk elemen yang kalau kita ada 2, 3 elemen atau lebih, then we have to repeat the same process untuk elemen-elemen yang lain. Kemudian kita assemble, then rearrange it in the form of system of a linear equation. So dia dah reduce kepada 6 kali 6 dekat sini selepas boundary conditions applied. So selepas boundary condition apply, yang aktif hanyalah 6 unknown degree of freedom. Sebab itu kita ada 6 equation. Equation 1, equation 2, dan ni adalah equation nombor 6 lah. So kita ada 6 equation, rearrange in the metric formats so that we can solve for the unknown yang kita nak tahu ni, dia punya displacement. So dalam this, kalau in case dalam you all punya problem memerlukan untuk dapatkan reaction kan dekat support tu, and then you have to expand lah the equation yang nak pakai saja. Let's say support dekat dekat sini kan, dekat ni, somewhere dekat sini, tapi which reaction yang kamu nak tentukan. So this is the reaction should be in the opposite. Let's say the reaction R X3. So tengoklah dekat sini, sebab sini dia pakai Q. So saya recommend kamu pakai UNV lah. Sebab pakai UNV tu kita straight away kita tahu U adalah force dalam displacement dalam arah X, V displacement dalam arah Y, dan dia punya subscript tu merujuk kepada nodes yang kita nak measure tu straight away kan. Kalau pakai Q1, 2, 3 ni kadang-kadang dia boleh ada dekat mana-mana je. Setengah orang some problem, we just provide the structures je untuk kamu. Then you have to decide which one is node 1, which one is node 2, 3 and 4. So setengah orang dia tulis macam gitu. Setengah orang, setengah student dia start dia start 1, 2, 3, 4. So kalau kita pakai Q1, 2, 3, 4, 5, 6, dan susunan dia dah jadi lain tau. Dia dah jadi 1, 2, 3 dekat sini, dan 4, 5, 6 dekat sini kan. 4, 5, 6. So actually dia tak kisah, tapi in term of nak marking tu, kalau 10 orang buat susunan yang lain, pening lah kepala saya nak cari satu-satu kan. So kalau kita pakai UV, itu lebih senang lah. Provided kita pun dalam this case kita dah fixkan the nodal point tu. So kalau boleh jangan ubah-ubah lagi lah soalan dia. Is it okay, guys? Up to this stage, untuk frame structure, kalau kamu pakai approach dalam ni, boleh try. Saya recommend kamu try. Then saya percaya kamu akan mungkin facing dengan apa tu error dalam result yang kamu hasilkan, daripada transformation. And then mungkin selepas kamu buat selesai satu rows pun kamu dah penat dah kat situ kan. So saya recommend kamu try, tapi untuk for the sake of the test exam, do not use that approach. Tapi gunakan approach yang kita supply dalam this separate document. So with that examples, I think we has completed our topics on the on the beams and also frame structure. Cuma nanti kita cuba dapatkan satu example which is example yang melibatkan apa tu symmetry punya structure kan. Kita nak tengok macam mana kita nak solvekan kalau structure tu symmetry. Alright, I think I'm gonna share